Good morning, Honorable present here. Myself P. Janagaratnam. In my previous sessions, I already discussed about the basic introduction regarding finite element analysis, as well as what are the applications of finite element analysis, and what are the softwares are used to solve this kind of finite element problems like ANSYS, FM, Nastron, and all discussed. Today I am going to discuss about the topic like general steps involved in our finite element analysis for solving the structural problems. Generally we have to follow 10 steps to solve this kind of structural problems. First of all, this is the history. FEA was initially developed in 1943 by R. Conrad to obtain the approximate solutions to vibration problems, and Turner et al. Published in 1956 a paper of stiffness and deflections of complex structures. And what is meant by finite element method is a numerical procedure to solve the structural problems. Like this method involves the modeling the structure using the finite number of small interconnected elements. Like this is the L sections. In this L sections, this is the one example problem. We can take the L section. The bottom of the L sections we are arrested, which means the degrees of freedom will be arrested, like x, y, and z direction. There is no displacement. And the topmost corner we can apply the point load, and what are the elongations may be taken care of these L sections and all we have to find out. First of all, this L section is converted into first step is we can discretize the given L sections. In that we can subdivide the smaller square elements, which means n number of elements. In our theory purpose we can subdivide it into 2 or 3 elements. For going to the software means we can subdivide it into n number of elements. So each corner point is called known as node, and the combination of these node points are called elements. Okay, this is the general finite element method to discretize the elements. And these are all the general steps involved our finite element analysis. First step is discretization. The first step is to select an element which closely represent the physical behavior of the structure. Physical behavior of the structure means based on their structures we can choose the elements. I already discussed either line or plane or solid elements we can choose. Then second one is for displacement function, as well as the we can numbering the nodes and elements of that particular structure. Displacement functions and interpolations functions are maybe selected based on their problems. Say displacement functions within the element using the nodal values of the elements is defined. They may be linear or quadratic or cubic polynomial. The same displacement function is used for the all elements. For example, we can subdivide it into 2 to 3 elements, means we can use the same function for the entire elements. Then third one is we can define the stress strain relationship. We can calculate the stress based on their load applying area, and strain means change in length to elongation of the length. We can combine these two, we can develop the stress strain relationship. After that, sigma x is equal to E into Ex. Sigma x means which is strain, and E is means Young's modulus of the particular structure or material, and which means Ex means the strain displacement matrix. We can combine these things. We have to develop the stress strain relationship matrix. And fourth one, we can derive the finite element equation for each elements. We can choose the normal finite element equation, which is F is equal to K into U. So automatically F means force vector, and K means stiffness matrix, and D or U means which means the displacement vector. F, in that format of F is equal to K into U, we can develop the finite element equation. Okay. Then fifth step is we can find out the we can assemble this individual finite element equations. We can find out the assembled global stiffness matrix. We can combine this element finite element equation 1 and 2. We can develop the assembled global stiffness matrix. The individual element stiffness matrices are then assembled to obtain our global stiffness matrix of the whole component being analyzed. And the sixth step is we can solve the unknown displacement by applying the different boundary condition, as well as we are taking the L sections. So the bottom node we are degrees of freedom will be arrested, so all the displacement values equal to 0. We can find out the other displacement values of the other nodes by applying the boundary conditions. And the seventh one is based on their displacement values, we can find out the stress strain at each element. And this and all are the basic steps we have to follow in our finite element analysis. And this is the types of analysis like structural analysis, linear and non-linear analysis, and thermal analysis, fluid flow analysis, and field analysis. In our first and second units we are studying the structural analysis, and for fourth unit we can analyze the thermal analysis like heat and heat transfer, like conduction, convection, and radiation problems. And fluid flow analysis and field analysis are other than that our subject we can study as like case study. Okay, thank you students. And our next class directly we can solve the problems related to finite element analysis. Thank you.